chapter 8 is, in fact, 8.3 when we start dealing with scientific notation. Okay, so 8.1. It's called products and powers. Products and powers. We're talking about exponents. So properties of exponents. For today. Remember, product, anyone can tell me what product is? Raise your hand. Taylor?
The answer to a multiplication problem.
That's right, answer to a multiplication problem. So you know right here, we're dealing with multiplication, and powers, just another name for exponents. So the product property is just like what we just talked about. X to the A power times X to the B power equals X to the A plus B power. If the bases are the same, and we're multiplying, you would add the exponents. Hopefully y'all remember this. That's why they review it. And then the power property. This one is if you have something in parentheses, like X to the A power to the B power. Anyone raise their hand how you handle this situation? Gabby? That's right. You're going to multiply the exponents. So X to the A times B power. I'll let y'all write that down. That is what we're doing today. Again, it's kind of like a review, but we're taking it up a notch from the last time y'all did this, getting you ready for the scientific notation stuff. Okay, so remember, if the bases are the same and you're multiplying, we add the exponents. Monday, if we get through this, which I know we will, that's when we are going to be talking about division. Does anyone remember what we do if the bases are the same and we're dividing? Aiden?
Subtract.
That's right. We subtract the exponents. Very good. So see, you remember. All right. So chapter 8 is not too bad. All right. 3x squared times 5x. Okay. Question. And again, most of this is kind of review or refreshing your memory. If I do not have an exponent here, what do I pretend it is, Emily? That's right. We pretend there's a 1 there. So if the variable or anything really does not have an exponent and you may need to deal with it, it's a 1. Okay, so are these bases the same? The x's are the same. We're multiplying, so what do we do to the exponents? That's right, we add them. Because the bases are the same, the x, we're multiplying, so we're going to add the exponents. So what is 3 times 5? Anyone? 15. x to the third. There's your answer. Any questions about what I did? Okay, so the numbers don't have to be the same because the exponents are attached to the variable. The variables are the same. So 3 times 5 is 15. The bases are the same. We're multiplying, so you just do 2 plus 1. It's 3. Any questions? Remember, if multiplying, add exponents. If base is same. If multiplying, add exponents. If base is same. Can y'all see in the back? If you can't, you can move out. All right, any questions so far? All right, let's do more. Let's take it up a notch. All right. -8 x squared y z to the third power times x y z to the second power. Okay. Write it down. Now, first of all, all of this, what operation is taking place with 8 and x and y and z, Gabby? That's right. All of this stuff, technically, even though it's a whole term, aren't you really multiplying anyway? Okay. And the x and the y and z, they're all really multiplying, correct? When it's right next to each other, that's multiplication. So really, all of this is being multiplied together, correct? It's not just this term multiplied by this term. You can look at it like that, but really, all of it's being multiplied. So let's see. I have a -8 here. Do I have any other number in here? All right, so -8 is our first part of our answer. Next thing, we have an x to the second power here and an x to the what power here? What power is this? 1. Okay, so if the bases are the same and we're multiplying, what do we do to the exponents? Anyone? You what? Add them. So then, x to the what power, Michael? Third power. All right, now let's look at our y's. Cecilia, what would the y be? 1 and 1. So then, in the answer, what would it be? That's right, y to the second power. Bases are the same. We add the exponents. And then z. Let's see, Aiden. And it would be z to the what power? 5. There's my answer. It looks uglier than it is. Any questions? None so far? Okay, so all you're doing is multiplying, kind of combining like terms sort of thing. Let's do another. How about if I have -ab squared to the third power? Make sure you are copying all these notes nice and neat too, by the way. Now, this time, A doesn't have an exponent, so what do we pretend is there? A 1. And back here, the power property, when the exponents are on the inside and outside parentheses, we multiply them. We do not add them, we multiply them. So we're going to multiply this 3 with the 1 and the 2. Draw those arrows. And don't let this negative fool you. That has nothing to do with the exponents. If the negative was attached to the exponent, yeah, we got to talk about that. But it's not. It's attached to the A. So 1 times 3 is 3. So negative A to the power of 3. And then 2 times 3 is 6. There's my answer. Negative A to the 3rd power, B to the 6th power. Any questions? All right, let's keep going. Let's again take it up a notch. I have negative 2 m to the 4th power n to the 3rd, with the all to the 3rd power, times 1 over 6 m n to the 2nd power, all to the 2nd power. I'll even draw a line here to, I should have probably dropped it a line. Okay, so sit back, look at it. I'm going to add a little note here. You're going to do exponents. Whoops, I'm running out of room. Exponents with parentheses first. So do the exponents with parentheses first. There's a star, exclamation mark. Do exponents with parentheses first. Y'all have that down? Do exponents with parentheses first. Okay, so we're going to start right here. This 3 is being, now this, y'all really need to pay attention to this because my students always mess this up. They'll apply the 3 to the n and to the 4, but they forget about this too. So we know there's a 1 there and a 1 here, but we also want to assume there's like a 1 here and a 1 here. Remember? So this 3 is being multiplied to that exponent, and that exponent. Draw your arrows. This 2 is going to be multiplied with that exponent, and that exponent. You have to make sure that that exponent is also applied to your numbers, not just your variables. So then this right here would become, and I'm going to keep it in parentheses for right now, negative 2 to the 3rd power, because 3 times 1 is 3, m to the 12th power, because 4 times 3 is 12, and then n to the 3rd power, because 3 times 1 is 3. Any questions so far? All right. this one would be 1/6 to the second power, because 2 times 1 is 2. M to the second power, because 2 times 1 is 2. And n to the fourth power, because 2 times 2 is 4. Write this down. Look at it before I move on. Ask questions now before we move on. You have to know how to do this. You're going to see a lot of this. Any questions? Okay, now we can start working it out. What is -2 to the third power? Taylor? -8. And I'm rewriting the rest of my problem. Do it step by step, guys, or you're going to make a mistake. What is 1/6 to the second power? Whit?
1/3. No.
1/6 times 1/6. Because it's 1/6 to the second power, so that means 1/6 times 1/6.
1/36.
There you go, 1/36. Good job. M squared into the fourth power. Okay, any questions where we got this? Speak now, forever hold your peace. Okay, now we start pretty much combining. It's all being multiplied. So -8 times 1/36. Remember, -8 over 1 times 1/36. Raise your hand if you got the answer. Taylor,
The full answer is rounded down.
give me the rounded down answer.
-8 over 36.
Rounded down
Oh,
answer.
rounded down answer. Okay.
And it's
-2
lowest
over 9.
terms, but I'm using your rounded down answer.
-2 over 9.
-2/9. So -8 times 1/36, as Taylor said in rounded down terms, is -2/9. Now, we have M and M, bases are the same. So Cecilia, what do we do to our exponents? You add them. So that would give me M to the what, Cecilia? 14. And then N to the what, Michael?
No, 7.
7. When the bases are the same, we add. There is our answer. And by the way, because this will be asked, put your letters in ABC order. Your letters should always be in ABC order. Any questions? Cecilia? Okay, good question. What is -8 times 1? And 1 times 36? Now we have to reduce that or put it in lowest terms. Do you understand? That's Taylor's rounded down answer. So like top and bottom can be divided by 4. Does that help? That's a good question. Are you sure you understand? Okay, so what we multiplied and then we put it in what's called lowest terms, Taylor. What?
So if it's like, so we just did in parentheses surrounded by and then going on the outside of the parentheses.
Yes.
What, so for division.
We're not doing division.
I know, I have a question on.
But can you ask the question tomorrow or Monday when we do division?
Yeah.
Thank you. Let's stay focused on multiplying right now. All right. So write your question down, and then on Monday you can ask it. Let's do examples, page 330. What, do you have a question?
Well, I'm just stating something. I feel like I'm gonna get it right now. And then when I go to the sheet, I'm gonna like, forget everything.
When you go,
Like to work it out on my own.
well, that's why we're doing a bunch of examples.
Oh yeah, that's true.
A bunch of examples that you write, keep your spiral next to you. And just remember, y'all have had this before, so don't stress, okay? All right, let's look at number 1. We're going to do lots of examples. All it says simplify. That means solve it. We have x to the third power times x to the fifth power. With, what would that be?
X to the 8th power.
See, you didn't forget. There you go. Bases are the same. We're multiplying, so you add the exponents. Any questions? All right, 3. Emily, you've been quiet. X to the second power times y to the third power times x to the fifth power times y to the second power. No, it's not. Remember, I always tell y'all it's uglier than it is. Okay, so Emily, sit back, relax. Remember the rules. What do you see here that you can combine? Yeah. The x's, same base, and we're multiplying, so what are you going to do to the exponents? Yeah. So then, x to the 7th power, and y to the... Yes. Telling me that's me. There you go. So you're going to add the 2 and the 5 of the x's, and then you move on to the y's. The bases are the same. You're multiplying everything together. So then you add the 3 and the 2 together. See? Not bad. All right. 5. First of all, any questions on 1 and 3? Cecilia?
Doesn't have to be X then Y.
ABC order. Now, last year, I didn't push that. I used to tell y'all should start practicing that. Y'all are going off to different schools. You're in Algebra 1, y'all need to start putting in ABC order. You're big kids now. Okay, good question. Y'all are having good questions. Any others before we move on? Okay. 5 is 3w to the third power times 4w to the fourth power. Michaela, how would you solve this?
The W's are the same, so you're gonna do 4 plus 3, which is 7. So it'd be, and then you do multiply with 3 and 4? Yes. So you'd multiply the 3 and the 4, and you'd get 3, 6, 9, 12.
12 w to the what power?
12.
What do you do to the exponents?
Oh, you add them.
So-
7.
7th power. There you go. So we're multiplying all this together again. 3 times 4 is 12. And then the bases are the same. We're multiplying, so you add the exponents and you get 7. I'll even do this. There you go. So you add the exponents, you multiply your numbers. Any questions? All right, let's look at 7. a to the 4th power to the 3rd power. Cecilia, did you do one? Yeah, you've done one, right? No? Emily, Whit. Okay, you do 7, Cecilia.
Equals
How did you get A equals 12?
4 times
Very good. She's correct. You're gonna, when it's on the inside and outside of the parentheses, you multiply. So A to the 12th power. Good. All right, number 9. Gabby, C to the 5th power times C to the 2nd power to the 4th power.
You gotta multiply the exponent in the parentheses by 4.
Okay, she's correct. We multiply this first. In fact, we do that first. So then we get C to the 5th power times what?
C to the 8th
That's right. We're going to multiply, when it's on the inside and outside, we multiply the exponents. So 4 times 2 is 8. So yes, now we have this. Good job. Now what do you do?
power. We're gonna add the exponent.
So now, this is why people get confused. We're multiplying here, but then we're going to add the exponents here because the bases are the same, and since we're multiplying them, we add. So what do you get?
We get C to the 13th power.
Very good. Make sure your notes are nice and neat so you can refer back to these. Any questions? All right. Number 11. See, Whit told you we're going to do a lot. And I do every year. Negative 2b squared c d to the 5th power, all to the 2nd power. Michael. Do what?
You multiply the 2 by all the numbers in the parentheses, including the whole number.
Okay, by their exponents, right? Okay, so if it helps to put a 1 there, then do it. So he's right. We're going to multiply that 2 by everything, all the exponents inside the parentheses. So then we get, and you tell me, Michael, negative 2 to the what power?
Second,
And then b to the
4th,
c,
second,
and then d. There you go. But that's not the answer. We got to fix this. So negative 2 to the 2nd power is what?
4.
Positive 4. Very good. The rest of these cannot be combined with anything, so we just rewrite it, and we're done. Good job. Any questions? Yes, ma'am?
I thought it would be a negative 4. Yeah, sure.
Well, the thing is, though, it's because of how it's presented right here. This is going on the outside of this, so it would be negative 2 times negative 2. I hate those because it's confusing. I know what you're saying.
I thought you would have multiplied the
You just explained.
negative 2.
It's negative 2 times negative 2. 2
Yes.
negative is a positive.
All right, 13. 2a squared times negative 5b cubed. Taylor. Do this one.
You just
Negative 2a squared. times 5.
What?
Wait. Oh wait, sorry. Alright, negative 10.
How'd you get negative 10?
Oh wait, distribute. Okay, I'm in limbo. Give me a sec.
You what?
Okay.
Wake up, Taylor. How do you solve this?
So you apply 2a squared to everything in the parentheses. So that would be negative.
Okay. Let me help you out. Okay? We're multiplying everything here. We're multiplying everything here. This is an a squared, that's a b cubed. Bases aren't the same, so really there's nothing to do with those. The only thing you're dealing with right here is the 2 and the negative 5. We're multiplying, so 2 times negative 5 is negative 10. And then it's just a squared b cubed.
I'm pretty sure I said something like that.
Right.
I said, okay, that negative 10a.
And I said, how did you get negative 10? Well, we're going to apply the 2a squared to the everything and the... Now, I get it. I'm just asking if you can explain it, and that's where everything went south. It's okay. It's the way your brain works, and I love that brain. Okay. Wait, you have a question?
Yes, ma'am. Why wouldn't, since the 2 is outside the parentheses, why wouldn't we multiply the 2 by everything in the parentheses?
That's what we did. That's exactly what we did. That's kind of what Taylor was saying. So it's 2 times this, and then we just bring down that.
He was talking about
No, but the exponent of 2.
The exponent of 2.
Like,
A and then the 2.
yeah, that one.
This?
Because it's not the same variable.
Yeah, the bases are different. The only time you multiply exponents is when you have this situation.
So only when there's just one exponent outside
Like,
the
yes,
parentheses.
exactly. Okay, that's a good question. Yeah. Does that help?
Yes, ma'am.
Okay, good. Good questions. All right, let's do another. 15. Taylor, you're going to redeem yourself.
Yes, please.
4abc times negative 3a to the third power bc.
Okay, so. Can I work it out and tell you the answer?
You talk it out. How do you solve this?
First thing you do is. Well, what you do is you multiply 4abc by negative 3abc.
Okay.
And that would be negative 12.
So we're going to do 4 times negative 3, which gives you negative 12. Okay, keep going.
And then a to the power of 4.
Because the bases are the same, we're multiplying, so we add the exponents. So he's correct, a to the power of 4,
And then b squared.
b to the power of 2, because that's really b1, b1. Bases are the same. We're multiplying everything, so then we're going to add the exponents.
And then c squared.
C squared, same thing.
I was trying to say cubed.
Any questions? So we are adding exponents. Any questions? You are asking really good questions, so don't be afraid.
The little c's would have 1s too, right?
That's correct. because there's no exponents there, so we put in imaginary ones. And since we're multiplying, we're going to add those ones, and we get 2. All right, let's look at 17. 5x cubed to the third power times 2x to the second power. Aiden, you want to do this one?
Sure.
All right.
So the first thing you do would you multiply the 3 and the first parentheses to 5 and x.
So we're going to put a 1 here, and the 3 is going to be multiplied to that 1 and that 3. And then the same over here, right?
Yes.
Make sure you don't do 3 times 5, guys. If you do 3 times 5, that's why I always put the 1 there, so that you guys don't go back and do like 3 times 5 is 15. Okay, so what do I get? We get 5 to the what power?
Power 3.
And x to the
Power 9.
power of 9 times 2 to the power of
2.
and x to the power of. Perfect. Now, Aiden, what is 5 to the power of 3? 125. X to the power of 9. What is 2 squared?
4.
4x squared. 125 now times 4.
500.
And x to the
Power
power of 11. So we multiply the 125 with the 4. And since these bases are the same and we're multiplying everything, we are adding the exponents. Any questions? Yes.
Well, I have a question on 15.
Okay.
If there wasn't the parentheses there, would it still be done the same?
Yeah.
Okay.
Absolutely. Good question. He said if the parentheses weren't here, would we still be doing it the same unless this was like minus 3 and you're subtracting? But if it was done like this is the like that and this was gone, you're still multiplying everything here. So it would definitely be done the same way. Good question. Any other questions, Cecilia? Right here, 5 cubed, it's 5 times 5, which is 25, and 25 times 5 is 125. Good question. Does that help? Any other questions? All right, number 23. Three b squared c minus c squared b plus 2bbc squared. All right. We are combining like terms. Oops. We are combining like terms. Taylor?
Can I do this one?
Sure. Can you handle it? Are you
Yes.
in limbo?
Yes.
All right, we're combining like terms. First of all, we're going to look at this. Notice that there's a subtraction and an addition sign. Pay very close attention. This is one group. This is one group. And this is one group. The whole thing is not being multiplied together. It is separated into 3 groups. Now, this stuff in here is being multiplied, right here is being multiplied and this is being multiplied. But because of the minus and the plus, we have 3 separate groups. So the first thing we're going to do is we're going to combine what we can in this group. So Taylor, what will this group look like if we combine it correctly?
3 times b squared times c squared.
Okay, I want y'all to look. See these two c's? They're being multiplied and the bases are the same, so we're adding the exponents, which he just did. Do y'all see that? Okay, minus. Is there anything I can combine here, Taylor?
No.
No. C squared b. Plus. Is there anything I can combine in that group?
So 2 b squared c squared.
So it's 2b squared c squared. Okay, because we combined the b's. I still have 3 groups. Now, I want you to look at the groups. Which ones are considered like terms?
The first and last.
Look here, guys. This is b squared and c squared, b squared and c squared. Do y'all see that? These don't match. So these two can combine. I need y'all to know this. These two groups can be combined because they have the same variables. Do y'all see that? So 3 plus 2 is what, Taylor?
5.
And then we just write b squared, c squared. And then we bring down that one, and there's our answer.
Where'd you get the 5?
3 plus 2 is 5.
So
Gabby? She had her hand.
for the negative c squared times b, wouldn't we have to put it in like ABC?
You absolutely can switch it around. That's probably a smart thing to do. She's saying put this in ABC order. And that would actually be the right thing to do.
So you don't add the 2 if they're the same?
No, because we're adding or subtracting. You only add exponents when we are multiplying the bases. So you don't have to add or do anything. You just bring them down, and there's your answer. Good question. Anyone else? No one? Does everyone understand how to do that? No? Kind of? Let's do one more and then I'll set you free. 25. 5x to the 5th power, y to the 4th power, minus 5x cubed, y squared, x, y, oh, I'm running out of space, cubed, plus 2y squared, x squared, y squared, x cubed, minus x 4th power, y to the 5th power. Okay, make sure first you copy it down from your book the way it's written. Once you do that, guys, circle your groups. Whoa, where'd this go? Okay. Circle your groups. It's easier on the eyes. Look. Now, we've circled the groups. What?
Can I do this one?
Yep.
Good job.
Circle your groups so it's easier to see what you're doing. All right, so Whit, I'm gonna move this over here. Is there anything I can combine in this first group? So I'm gonna rewrite it. I'm gonna bring down my subtraction sign. Whit, is there anything I can combine in this group?
Yes, ma'am.
What?
The X and the X, and then the Y and the Y.
That's right, the X and the X. Should be a little 1 there. And then the Y and the Y. We're multiplying here, so we add exponents. So I have negative 5x to the what?
4th power.
Y to the?
5th power.
Very good. Plus, can I combine anything here?
Yes, ma'am.
What?
The Y and the Y, and the X and the X.
That's right. We have bases that are the same. So it's, let's do it in ABC order. Let's do the X's first. So it's 2 to the X to the what?
5th,
And Y to the?
4th.
Good. Minus, because I'm bringing down my minus. Is there anything I can combine in this group?
No, ma'am.
So it's just X to the 4th, Y to the 5th. I'm going to, again, circle my groups. It's easier on the eyes and brain. Now, I'm going to look to see if there's any that are like terms, like identical X's and Y's. And are there any?
Yes, ma'am.
Which ones?
The second one and the 4th one.
Second one
Oh,
and the
wait.
4th one.
I didn't write down.
Because look, it's X4, Y5, X4, Y5. Good job. What about these two?
Oh, yes, ma'am. They are.
X5, Y4, X5, Y4. So these two can be combined. So with 5, look up here, 5 plus 2 is what?
7.
And then I just bring down the X5, Y4. Finish those. And then here I have negative 5 minus 1. What would that be?
Negative 6x.
6x.
Oh, to the 4th, and then Y to the 5th.
And we're done. Any questions?
This is overwhelming.
All right, you're doing page 330, numbers 14, and I'll give you some time in science too. Whoops, wait, hold on. Eight to 26, even. That's 10 problems.
We get the 2 largest problems, or 2 and 3 largest.
Honors. You get to do 12 through 26 even, and 36 and 38. This is due Monday. Get started, and I will give you time in science to also work.